only water, but B is salt and water. Raise your hand if you think the salt has anything to do with the eggs floating. It must. Right, most of you have your hands up. It must, because no salt they sink, salt they float. Okay. Now, how many of you knew before today that you can make an egg float with salt? Okay, that's typical. I find that most of my fifth graders that I'm starting with have seen an egg floated with salt and water at the Science Center or on TV or something like that. So I'm starting out simple. The focuses are going to get more complicated as I go along. The reason I'm starting out simple is today I'm just trying to teach you the rules of the game and the methods I use. So I don't want you to be confused by having a really complicated focus. Okay, so let's see, I want to look here because liquid A contains only water, but liquid B doesn't contain only water. A is only water, but B is salt and water. All right. Now, does anybody know what the salt has to do with the eggs floating? Who wants to try to explain why the salt makes the eggs float? What do you think, Brandon?
Because the salt has more has more air in it than water.
What do you think, Janelle?
Because in like at the ocean, like salt water, the salt. Because if you go with the water in the ocean, the salt pulls you up in the water. So.
Okay, Jessica, what do you think?
Because there's sodium in it.
Trish Hunter, please come to the office immediately.
Sodium.
Okay. Here's a diagram I want you to write near the bottom of your paper. The top of your paper is going to be occupied by that. Near the bottom of your record sheet, write this diagram. Less dense over more dense. That's a very simple diagram. It looks like a fraction. But it describes a universal law of science. And I'll explain it. We're going to deal with this quite a bit this year. If you add salt to water, it makes it more dense. And I'll explain density in a minute. Because most people, including most adults, don't understand the difference between dense and heavy. Okay. If you have this line, in this diagram, this line stands for any liquid, water, alcohol, olive oil, any liquid, mercury, which is a liquid metal. That line stands for a liquid. Okay, if you have a bucket of the liquid and you put an object in the liquid, if it floats and goes up, it's less dense than the liquid, and if it sinks, it's more dense. So we know that both eggs are more dense than A, but they're both less dense than B, see? Even though they're the same egg. All right? So that's a universal law that applies to all liquids. It actually applies to gases too, but we won't get into that till later in the course. So if I gave each of you an unknown liquid, if I can find 25 different liquids, a bucket of liquid, and I gave you an object and I said, I want you to find out whether this object is more dense or less dense than this liquid. Who can tell me what you'd do to find out? What would you do, Nathan? No, not as, well, yeah, if the object was an egg. All right, let's suppose the object I gave you to test was an egg. How would you tell if the egg was more dense or less dense than that liquid? Allie?
You'd get a partner and switch your eggs.
No, you wouldn't necessarily switch them, Darby. I mean, it's real simple. Would you put the object in the liquid?
Yeah.
How many say you put the object in the liquid? Okay, then what would you look for? Megan?
If it floated or swam.
Right, if it floats, it's less dense in the liquid, and if it sinks, it's more dense in the liquid. And some things will float in mercury, which is the most dense metal I know of, dense liquid I know of. That's the shiny liquid if a thermometer has a shiny silver column, that's mercury. Some things will float in mercury, but they won't float in salt water. Some things will float in salt water, but they won't float in fresh water, because those liquids all have different densities. Okay, now I think it's time for me to explain dense, and then remind me to add to the conclusion, because after I explain dense and density, I want to add to the conclusion, and I'm going to explain it with these empty water bottles. Okay, these are pint bottles.
We can't see that.
A pint of water weighs a pound. So if each of these was full of tap water, fresh water, this would weigh a pound on the scale, and this one would weigh a pound on the scale. But if this one was full of salt water, it would weigh more than a pound, because salt water is more dense. Okay, now I think most of you also know that if both of these were full of tap water, this one would weigh more, just because it's bigger. All right, but if this one was full of salt water and this one was full of tap water, this one would still weigh more because there's a lot more of it, but it would be less dense because it's fresh water. This one was filled with salt water, it would be more dense, but it would weigh less. You might be confused about it at this point, but there's a big difference between density and weight. Okay, so here's another thing to think about. Mercury is the most dense liquid that I know of. It's about 20 times as dense as water. Okay, if you had a water bottle full of water, it would weigh a pound. How much would a water bottle full of mercury weigh? Can anybody figure that out? Jessica?
20 pounds?
20 pounds. It's so heavy I could hardly lift it. Right. Now, if I had a water bottle full of oil, you should all know that oils float on water.
Yeah.
That's because they're less dense. Okay, if you had a water bottle full of, say, olive oil, would it weigh more than a pound? How many say it'll weigh more than a pound if it's full of olive oil? How many say it'll weigh less than a pound? It'll weigh less than a pound. Okay, so here's a game you could play with your parents now that you know about density. I'll bet most of your parents don't know the difference between density and weight. So here's what you could do. You could get 3 water bottles. Most of you can round up 3. They have to be identical now. You put fresh water, tap water in one. You put salt water in one, and you put cooking oil. You fill them clear up to the top. All right, now you take a bucket of tap water, big enough for these to float in. Okay, and you ask your parents to predict which ones will sink and which ones will float. Okay, well you let them hold them first, and they find out that they're heavy. They weigh about a pound, so they're relatively heavy. And a lot of people will predict that all 3 will sink. Okay, you take the one with the tap water in it, and you put it in a bucket of water. It doesn't sink, but it's under the water so that the cap just barely sticks out. Here's why. The tap water inside and the tap water outside have the same density. But the plastic bottle is less dense than water. Plastic floats. So the combined density of the water inside and the bottle is slightly less dense than the water in the bucket. So it won't do what you call floating, but it won't sink either. It'll just have the cap barely sticking out. Okay, now most parents wouldn't predict that because it feels so heavy. Okay, then you ask them, you let them hold the bottle full of salt water, and you ask them to predict whether that'll float or sink. Well, it's so heavy, it weighs about a pound, so almost everybody will predict that it'll sink. And it will. Why will it sink? Who knows why it will sink? It's more, the salt water is more dense than the fresh water. But here's the really clincher. You let them hold the bottle full of cooking oil. Now that weighs almost a pound. So almost everybody that doesn't know very much about density will predict that this will sink in the water. You put it in and it floats. Why does it float? Why does it float, Emily?
Because it's less dense.
The oil is less dense than the water. Okay, well, we'll work with density a lot this year, and I'm hoping that at least a few of you understand the difference between density and weight now. But here's something, I told you to write that diagram, and I'll write it again, because you've had an explanation of it now. Things that are less dense float, and things that are more dense sink, if you put them in a liquid. All right, now here's a statement to write that explains this diagram. Write this is supposed to be near the bottom of your page. Now some are either right above it or below it. Write this: things float better in more dense liquids. All right. So the reason that the eggs float better in the salt water is because it's more dense. When you add salt to water, it makes it more dense. What, Stevie?
So, we're not done with our conclusion, right?
I have a hearing problem. Talk a little louder.
We're not done with our conclusion.
No, we're not done. Right, we're not done with the conclusion, and not quite. Okay, now, let's see. Because liquid A contains only water, but liquid B doesn't contain only water. A is only, B is salt and water. That makes B more blank, 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 blank. Who knows what goes in the 5 blanks? What word? More what, Kendall?
Dense.
Right, that makes more dense. Okay, and then you have this and this, so that gives everything you need on this first record sheet. Wyatt?
Oh, if you put a rock in it?
Try it at home and see. Generally, rocks sink in water. Why? What?
Because they're heavy.
Why do most rocks sink in water?
Because they have more dense.
They're more dense than water. Most rocks are more dense than most water. All right, so that's the end of the first focus. All right, now we've got eggs C and D. I'll put egg C in liquid C. It sinks. Egg D in liquid D. It floats. So the problem is, why does egg C sink in liquid C but egg D float in liquid D? That's what we're going to try to solve with our conclusion. All right. Now I'm going to see if somebody learned something important with the first focus. This is either happening because the eggs are different or the liquids are different. Raise your hand if you can suggest an experiment that would tell us whether it's because of the eggs or the liquid. Darby?
Who puts XC in liquid B?
Okay.
In liquid C.
We could switch the eggs, and that calls for 2 experimentation questions. Who remembers what 2-letter word an experimentation question always begins with? Jake?
Wait, I forgot.
What, Stevie?
F.
If you put egg C into liquid D, will it float? All right, who can tell me how to word the other experiment? What's the simple thing I have to do to word the other experiment? Emily?
Just swap the letters.
If you put egg D into liquid C, will it sink? Okay, again, these are experiments I can do, so I'll do them. All right. Take D out of here. Put C over here. It floats. And I'm gonna put D over here. Raise your hand if you think it'll float. Raise your hand if you think it'll sink. You just did some thinking. You observed what happened here, got some data from it, applied it here to a conclusion. Okay. So the answer to both questions is yes. Now, raise your hand if you can tell me what those two experiments just proved. They just proved something very important. Wyatt? The liquids are different. Did they prove that the eggs are the same?
Yes.
No.
No, they didn't prove the eggs are the same. The egg might be the same or they might be different, but it proved that it's because of the liquids. So we don't have to ask any more questions about what? Eggs. What, Stevie?
You can also tell that the liquids are different because in liquid D it's more blurrier.
Okay, but swapping the egg proved it. Okay, so now we just have to ask about the liquids, and I'm not gonna write, I'm not gonna write the word liquid anymore because we know we're talking about the liquids. Okay, so we're gonna ask this. Does C contain any blank? Oh yeah. Well, that's water. It looks like water, right? So that's a logical question, isn't it? Yeah, C contains some water. Oh, and who knows the control question? Raise your hand, Tanner.
Does D contain any water?
Does D contain any water? Yes. All right, we know that they both contain at least water. So what's the next question we should ask about C? Next question, Mason.
Does C have another liquid?
Okay, well, another way of putting it is, does C contain only water? No, C doesn't contain only water. All right, somebody that hasn't participated yet, tell me the control question for 5. Allie,
Does D contain only water?
does D contain only water? No. Oh, I forgot. Just based on item 1 and 2, I could have written a conclusion. Here's what it would have been. Because liquids C and D are different. We know they're different because the eggs both sank in one and both floated in the other. Now, we can call that valid, and we can call it reliable, because it's supported by the data, and it's not refuted by any of the data. Who remembers from the last session what the word refute means? Emily?
It means prove that it's not true.
Prove false, right. Those data don't prove this false, but it's not a good conclusion, because a good conclusion would tell you